Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So this is interesting. This is the first step. So how to make it unique? We have found out the solution by making it non-terminating. Great. So with this arsenal of ideas in our mind, what we'll do is we'll march ahead to understand something, and it's very interesting. So we'll show that the set of all real numbers such that x is between 0 and 1. That means this is uncountable. And the proof is very elegant. Just one step. Just understand and just immerse yourself into this beautiful mathematical proof. It's very elegant, okay? Very clever, very elegant, and you will love it. Very simple. So we do a method of contradiction. So we assume that it's countable and we show a contradiction, right? So let's assume that um, this set is countable. That means there is a function from natural number to this set, right? So you can actually find numbers like f1, f2, f3, f4, f5, like this goes ahead, and they have a decimal expansion, unique non-terminating decimal expansion, right? That's a 0.1235 976 dot dot 0.315762 dot dot 3 0.11354 dot 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 0.4146362 then 0.515678999 dot dot. Okay. So what we do is that from this set of numbers we find another interesting number. So what we do? So we take the first element out here, the second element out here, the third element out here, and the third one, the fourth element out here. I mean, you understand there is some probably. To make it visually appealing. Here, so that means there is a function, bijective function from natural numbers, bijective function from natural numbers to this 0, 1, right? It's a bijective connection, bijective function. So if it's a bijective function from natural number 0, 1, so therefore 1 goes to this. Let's assume that 1 goes to this number, okay? Let's assume that let's assume that 2 goes to this number, 0.315 number, right? 3 goes to this number, 4 goes to this number, 5 goes to this number. Does it make sense? So now what to do? We find a new number. What we do is that let's call it 9. So what we do is that so we found a new number. That means we take 0.1. The first element that you have got, we change it to add 1 to it. 2 plus 1. The second number, we place it in the second place. Let's say it's 2 again. We add 1 to it again. The third number, we again placing in the third place. We add 1 to it again. The fourth number, we're adding 1 to 4 again. We're adding 1 to it again. This number, oh, I'm sorry, I gave the wrong colors. Blue, red, purple. So now what do we do for 9? We cannot add 1 to it. What we do is that we add 1, so it becomes 10. So we go to 0. Okay. So 9 goes to 0. Everything gets added to 1 because 9 goes to 10 and 10 goes to 0 in the fifth place. And for whatever we have got in this sequence, we define a new number like this. All of you understood this definition, guys? So define a number like this, right? So now what we will do is the following. Now this number, this is also a real number between 0 and 1. Now this number, this interesting number is some function because it's a natural, it's a bijective one. So there is some like natural number n naught. So this number is equal to this number. This is the second argument. Did you understand this? So this number, since it's a bijective function, countable set, so for some integer, let's say 1379978, that integer is this by the definition, by the assumption, right? Or let's take it, or you can also, it can be 17th also, f of 17, just one such number, unique number, right? Now the contradiction comes here. So how it is defined? Contradiction comes here. For this number, how is defined? So let's take it this, let's assume it's 17. F of 17 is equal to this. That means if it continues like this, at the 17th position, what will you have? So what we are doing, at the 17th position, what will happen? We're taking f of 17 and we are changing the 17th number, 17 decimal point to plus 1. Let's say the 17 decimal point is 3. So that means, now understand this f of 17 is this number only, right? So what we are saying, the f of 17 is this number only, and also we are saying at f of 17th position, this number has that position number plus 1. You understand? By if f of 17 में यहाँ पर 3 है, if in f of 17 there is 3 here, then what we are doing, we are adding 1 to it by the definition of this argument, by the definition of the formation. So essentially, by forming this, it's a 4 by the definition how it's formed. So we are assuming that, let's say this number is countable, like this set is countable, so there is a number, let's say 17 on n, for which this number is equal to that the f of 17 is equal to this number because it's countable and it's a bijective. F is bijective and we are assuming it's bijective. But the way we are defining this function is that at 17th position, this new number is defined in such a way, at 17th position, if it's 3 in the actual number, we add it to give 4. Therefore, this is a discrepancy. That means this f of 17, this number has both 3 and 4 in its position, which cannot be possible, right? Hence, it's a contradiction. Did you understand this, guys? No, yes.